Dear students, today we have to define spherical refracting surface. So first we have to see this figure number 1. So here xy represents a curved surface and it should be a transparent material. It may be glass, and this curved surface xy is a part of a sphere. So this curved surface xy is known as spherical refracting surface. Sigi figure number 1 sida ulise sigi xy je curved surface ni curve oiba ko cone ba adu sigi curved surface se sphere amagi saru oigadaba sigi xy jina sphere am form to bo yagani adu sigi curved surface xy se light na irai line na far set pangam wadaba glass kum bai tare ko aduna moi je kari ka weda spherical refracting surface kawe aduna spherical refracting surface may be divided into two types. Makal ani thona khai to pa yai. Number 1 the convex spherical refracting surface, number 2 the concave spherical refracting surface. Aduna spherical refracting surface apoi na smile define to pa yai. It is a curved refracting surface which forms a part of a sphere. It has two types. Number 1, convex spherical refracting surface. So it may be defined like this. It is a spherical refracting surface which is convex, that is bulging towards the rear medium as shown in figure number 1. And see figure number 1 the is a convex spherical refracting surface or the number of the carigino high tardy sidalariba curved surface xy light na yaigadaba surface xyz rear medium. It may be ear nuksip oibay rear medium long the pong thuoga laiba bulging surface the convex surface bulging surface aduna rear medium long the tong thuoga pong thuoga laiba curved surface or the convex spherical refracting surface kautare. And Roman number 2, concave spherical refracting surface. So we may define like this. It is a spherical refracting surface which is concave, that is depressed towards the rear medium as shown in figure number 2. So figure number 2 the pulisina concave spherical refracting surface ni maram di karigino ita distal curved surface se rear medium ear from the cushion concave that is depressed. Next we have to discuss refraction of light through a spherical refracting surface. It may be discussed in two cases. The first one is when object lies in rear medium. So first we have to see this figure. So here XPY represents a convex spherical refracting surface, and P represents the pole of this spherical refracting surface, and capital C represents the center of curvature of this XPY. Center of curvature means the center of the sphere in which this spherical refracting surface XPY forms a part. So here O represents a point object and U represents the distance of the object from the pole, and we have to consider a ray of light OA emerging from this point object O and incident on XPY. And here object O is placed in the rear medium having absolute refractive index mu1, and this mu2 represents absolute refractive index of the denser medium, that is spherical refracting surface. So here I represents angle of incidence, angle between incident light ray and the normal at point of incidence capital A. So in this figure CN, this dotted line represents a normal line and it should be always passing through the center of curvature. So here light is traveling from rear medium to denser medium. After refraction, the refracted light ray bends towards the normal and meets the principal axis at capital I at a distance b from the pole. So here I represents the position of the real image formed by this spherical refracting surface XPY for this point object O. ꯑꯗꯨꯅ ꯁꯤꯗ ꯎꯔꯤꯁꯦ O sina object ni object se koina real medium da thambani sigi object sigi image sina I je oidoni and U sina object distance, B sina image distance, capital R sina radius of curvature. O hai tadi P ga U hai badi P ga O ga arapa object distance, R hai badi radius of curvature, center of curvature ga pole ga ani ji arapa. B hargana image distance, capital I ga capital P ga ani ji arapani. Ana sigi da ladies koina alpha, this angle alpha represents angle between incident light ray and the principal axis. Principal axis is the straight line passing through pole and central curvature. And beta, angle beta is na angle between refracted light ray and the principal axis. And this gamma represents angle between the normal line CN and the principal axis. So from this figure we have to derive a formula between U, B, R, mu1 and mu2. The sigi figure is the formula derive kari relation markta U ne, B ne, R ne, mu1 ne, mu2 ne. So we may write like this. Let XPY be a convex spherical refracting surface having radius of curvature capital R and made of a material whose absolute refractive index is mu2. A point object O is placed on the principal axis in the rear medium having absolute refractive index mu1 at a distance U from the pole capital P. A ray of light OA is emerging from the point object and incident on XPY, making an angle of incidence I. Since light is traveling from rarer medium to denser medium, the refracted light ray bends towards the normal CN, making an angle of refraction small r and meets the principal axis at capital I at a distance b from the pole. Hence, I represents real image of the point object O. Then AM is drawn perpendicular to the principal axis such that M is very close to P. Alpha, beta and gamma be the angles formed by incident light ray OA, refracted light ray AI, and the normal CN with the principal axis respectively as shown in figure. Ana sigi figure is the ule huzik sarna khai myam do next la tu je when Snell's law apply to run sigi figure is the call on applying Snell's law on Snell's law na kari haiba sine I by sine R, sine of angle of incidence divided by sine of angle of refraction se kari manaba relative refractive index of the medium, karma medium, refracted light in the level medium, that is denser medium with respect to the rarer medium. Now when apply Snell's law, then we may write like this: sine I divided by sine R equal to relative refractive index of denser medium 2 with respect to rarer medium 1. Mu 2 1 is the relative refractive index of denser medium 2 with respect to rarer medium 1. Sigi mu 2 1 is minus iba absolute refractive index of denser medium 2 divided by absolute refractive index of rarer medium 1. So let it write equation number 1. Next up, we will see the angles, angle of incidence I, angle of refraction R, alpha, beta, gamma, angle myam je koina yamna pick pa angles ngakne na low selo. Then angles jam pick tar de koina sine I je I ga mani lo bai sine R je R ga mani lo bai aduna mathang da koina smai iraje. Let us assume that I, R, alpha, beta and gamma are very small angles. Then sine I approximately equal to I, and sine r approximately equal to r. Angle is pick target the sine I is I dang hai bi sine r is na r dang lo bi. Aduna similar equation number 1 je we may write like this. So therefore equation 1 becomes sine I by sine r mota I by r dang iro, and this will be equal to mu 2 by mu 1. Equation number 1 di lapani sine I mota I iro, sine r mota r iba. So cross multiplication tawkanda I into mu 1 equal to r into mu 2, and write it equation number 2. On mathang dang lao to is na koi na sigi angle I ga angle r ga se in terms of alpha beta gamma da mo express tau dine ba. Aduna sigi figures de koi na triangle angle of incidence I yaw ba triangle ama choose tau tare. Adu ki triangle du di sigi figures de gi AOC je lo se ba, triangle AOC je. Triangle AOC da angle I sina exterior angle oirani, aduga alpha ga gamma aga sina two interior opposite angles. Aduna koina khangi se kaino triangle amagi exterior angle je magi two interior opposite angles anidugi samga manani. So from this figure we may write like this: angle I equal to alpha plus gamma. Aduni matang di idui je. So from triangle AOC have triangle is the lower C, exterior angle I equal to the sum of two interior opposite angles, that is alpha plus gamma. I equal to alpha plus gamma la hai. And apoi na sida angle the pyam je small angles matri na alpha ki mota tan alpha hai ko samane, gamma or su tan gamma no san bayai. Tan alpha je alpha hai ko samane, tan gamma je gamma hai ko samane. Maram di angle sing am pick pagini. Aduna sigi right triangle demo tan alpha tadi, let us consider right triangle AMO. AMO have a right triangle is lower kanda tan alpha tadi perpendicular by base, that is AM by MO, or the AM by MO later. Tan gamma gana say let us take right triangle AMC, aduna perpendicular by base AM by MC, or tan gamma mota AM by MC iro. Then according to low risk AM is very close to P, that is pole of the refracting surface. Aduna M ga P ga yam nang na point ni, aduna approximately when MOZ PO hai ba yai, AMC de PC hai ba yai. Aduna AM by PO plus AM by PC is na kari mana ba angle of incidence ka mana ni. So write it equation number 3. Similarly, let us take triangle ACI. ACI have triangle jim lower jim maram karigino r small r to in terms of angle beta and gamma da. So here gamma represents exterior angle and r and beta represent two interior opposite angles of this exterior angle gamma. So we may write gamma equal to r plus beta. So from this r equal to gamma minus beta, and again we have to put tangents. So instead of gamma and beta, we may write tan gamma minus tan beta, because gamma and beta are also very small angles. So we may write like this: tan gamma from right triangle AMC perpendicular by base AM by MC, tan beta. Tan beta gana triangle right triangle AMI jalo. Right triangle AMI degi tan beta di perpendicular AM divided by base MI hai ba. Auna AM by MC minus AM by MI later. And again from this we may write like this: instead of say capital M, we may put capital P, that is AM divided by PC minus AM divided by PI, and write equation number 4, because AM and P are very close to each other. Next is equation number 1 the angle of incidence I, adu angle of refraction R do, adu mota equation number 3 ga 4 ga da P riba my value do sinjalani anopinas my VRA. Now equation 1 becomes I mota AM by PO plus AM by PC into mu1 equal to small r mota AM by PC minus AM by PI into mu2 euro. Then AMZ both sides the loina common way the cancel sacro, then see fast bracket open tawro, so we may write mu1 by PO bracket open tawro mu1 by PC. But on the right side there is now mu2 by PC bracket open tawro kanda niko minus mu2 by PI. AMZ loina cancel sacro from both sides. So write equation number 5. Then again we have to apply sign conventions. Quantity the object distance, image distance, the radius of curvature r je plus lawdra minus lawdra hybrid muk la je sign convention ki rule to apply to kanda aduna PO so your PO je kai madare object distance adu measurement of object distance ki direction je opposite to the direction of incident light ray a on a certain direction jiga measurement of PO opposite oi aduna object distance je sign convention ki matungina negative oirani on a POJ minus U then again PC radius of curvature, direction of measurement of radius of curvature, that is from P to C is along the direction of incident light ray. Aduna PC je positive value plus capital R then image distance PI have the V gamane image distance on the direction of measurement of image distance, that is from P to I along the direction of incident light ray OA. O in a saliba direction ka image distance on the direction ka some manai aduna positive oirani. On equation number 4 the 5 the yariba PO mota minus U sinjalani, PC mota plus R, PI mota plus B sinjalani. Therefore equation 5 becomes mu1 by minus U, PO mota minus U plus mu1 by P sigmoid plus R equal to mu2 by P sigmoid R minus mu2 by P sigmoid V semai lai. Matang sigi matang da lau tu je sidi yang mu2 by V right side level term je left side por ani auna sigi minus mu2 by V je plus olani mu2 by V minus mu1 by U selai minus mu1 by U equal to mu2 by R silai left side plus mu1 by R je right side pork and the minus la ani. So we may write mu2 by V minus mu1 by U equal to mu2 by R minus mu1 by R. Then right side capital R je common logo yai, that is LCM lo R je common logo aduka mu2 minus mu1. Finally we may write like this mu2 divided by V minus mu1 by U equal to mu2 minus mu1 divided by R, and write it equation number 6. So equation 6 represents the relation between object distance U, image distance V, radius of curvature capital R, absolute refractive index of rearranged medium mu1, and absolute refractive index of denser medium mu2 when object lies in rearranged medium having absolute refractive index mu1.